this video we are going to talk about using u-substitution to evaluate an integral. So in this integral we actually have a definite integral, which adds another step to this process. There's two ways you could handle it. I'm just going to show us one where we change everything to be in terms of u. So in this one, I know I'm going to use u-substitution because when I look at this, I have an inside function, which is 4 minus x squared. And even better, I'm now multiplying my outside evaluated at my inside times the derivative of the inside. Now this isn't precisely the derivative of the inside function, but it's the derivative times a coefficient, so that's acceptable. So in our u-substitution, we start off by choosing u. Well, our u is always our inside function, which for us is 4 minus x squared. Next, I take the derivative of that, which is negative 2x, and then I try to solve for dx. So I get dx is du over negative 2x. Now the reason I wanted to find dx is because when I use u-substitution, I have to get rid of all x values. So I'm trying to get rid of the dx as well. We want only u in our final integral. So now let's start to plug in. Let's ignore limits of integration right now. And instead of writing dx, I'm going to write the du over negative 2x that we came up with. Now you'll notice that the x here cancels with the x here. And that's exactly what you would hope would happen in a u-substitution. You want all of your x's to go away. Now we haven't talked about the limits of integration in this yet. So in my opinion, the easiest way to do a u-substitution when you have a definite integral is to switch your limits of integration into u values. These values here are x values. And since our integral is now in terms of u, we want to have u values as our limits of integration. So I start by plugging in one u value at a time into my u equation. So I have 4 minus 4, which is 0. And then I'm going to plug in my second limit of integration, which is 2. And again, that will get plugged in to the 4 minus x squared. So u will be 4 minus 2 squared, which is 4 minus 4, which is 0. So let's add our limits of integration on now. So now you'll notice we have an integral from 0 to 0, which actually we could take the easy route and just say, well, that's just 0. Because any integral that's integrated from a to a, or one limit to that same limit, always comes out to 0. There's no area under that graph. But for practice, let's just go ahead and see how we would handle this. So we have an integral from 0 to 0 of cosine of u. We take its antiderivative, we get sine of u from 0 to 0, and we plug in 0. We get sine of 0, and then we plug in 0 again, since it's both our limits of integration, and we'll just get 0. All done.